Tulsa, Oklahoma, the oil capital of the world, built on the backs of oil and steel, welders, riggers, and roughnecks, a city defined by hard work, perseverance, and grit. It's known boom and bust, and through it all, for over 100 years, Tulsa has been the home of McKissick, where crane blocks, snatch blocks, construction blocks, oil field blocks, and specialty blocks and sheaves are made.
From ancient pulley systems used by Greeks and Romans, crane blocks have evolved to be highly engineered, application-specific tools needed to lift incredibly heavy loads. Kito Crosby manufactures the widest range of blocks right here in Tulsa, Oklahoma. Making a McKissick crane block takes a lot of hard work, and the folks here at Kito Crosby are going to show us how it's done. Hi, Andy.
Hey, Ben. Welcome to Kito Crosby in Tulsa, home of the McKissick blocks. So I'm product manager over blocks, sheaves, and engineered solutions, which is the majority of the product that comes out of this facility here in Tulsa.
So today you're going to walk us through the process of making a block. Can you tell me a little bit about what we're going to see today?
We're going to see the whole process, starting from engineering and then going through creation of those lower level components to the final assembly and shipping it out the door.
What do you do if you need a block or a sheave?
Reach out to our distributors, Mazzella being one, and they can get you in touch with us to get the block that you need to fit your application.
All right, should we head on back and find out how they're made?
Absolutely, let's get started.
Our first stop is at the very beginning. What happens when an order comes in and engineering begins?
We work with the construction industry a lot. Crosby has a really rich history with the oil and gas industry, offshore mooring systems. There's products we make that are in factories, workshops, all across the globe. So my name is Matt Wantland. I'm the sales manager for the BS&E division here at Kito Crosby. You know, it's interesting because we have a very old product line. On the other hand, you know, we're making new product every day. We get new and interesting requests every day. If it's a new product, it's going to go to engineering, make sure it's engineered properly to our internal specifications, structural specifications, quality, etc. That's going to turn into a drawing approval process. They'll approve that. And at that point, we go into production. From day to day, I just never know what kind of challenges we're going to get into or what kind of new projects we're going to get into. I think the products are neat, interesting, and the people are just fantastic.
Once the customer approves the engineering drawings, procurement begins. Raw materials are sourced. Hooks are forged in Crosby's facility in Longview, Texas, and sent here to Tulsa. Incoming steel needed for blocks is sent to the lab to undergo rigorous inspection. After a safety briefing and checking that we had the required PPE, we were off to the lab to see how the steel is tested. In the lab, the source steel is tested to validate that it meets Kito Crosby's requirements for their blocks. Hardness tests are performed on samples of the steel. A tungsten carbide ball is pressed into it using a specific calibrated amount of force. This indentation's diameter is then measured. From this measurement, the steel's hardness value is calculated, and that hardness needs to match Kito Crosby's exact requirements. Next, the steel's chemical composition is verified. A laser is shot into the steel, vaporizing a very small amount of the surface. The laser gun pumps argon around the burn, allowing the light released from the burn to be analyzed by a spectrometer. The different colors and wavelengths of the light are read, allowing the instrument to identify the steel's chemistry and confirm the amounts of about 15 key elements. When the quality of the steel is confirmed, the steel plates are ready to be cut. At the laser table, large steel plates are precisely cut to form the exact dimensions for each part of the block. Some of these components will end up being the side plates or brackets, while others will be sent to the forge to become the sheaves. Since 1977, McKissick sheaves have been roll forged, a process that not only enhances strength and durability, but also reduces material waste. It's this proven method that has helped establish McKissick sheaves as some of the most trusted in the industry, something that has set McKissick apart for decades.
We unapologetically can say that we have the best sheaves in the world right here in Tulsa. So here is where the magic really happens. It's where we forge our sheaves. So what you'll see a lot in the world is cast ductile iron sheaves. Because we're forging that groove into the sheave, one of the beautiful things about this process is that we don't have to do any machining on the groove after it's formed. We get strength characteristics of the forged component at a reduced weight.
The steel blanks cut at the laser table are now rolled into an oven and heated to a specific temperature. From there, skilled operators move the red-hot blanks into Kito Crosby's proprietary roll forging machines. Operators upset the hot steel rim, forming the groove directly into the sheave, without requiring any machining or the creation of a stress zone at the splitting point. This process provides superior strength, durability, and longevity to the sheave, at the same time reducing weight and the time required for the manufacturing process. Shaping steel under this kind of heat is demanding work, but it's the craftsmanship of these operators that defines every McKissick sheave. It's the kind of work that these crews have carried out for generations here in Tulsa. Once the groove is formed, the sheave, or at this stage what is referred to as a donut, is removed from the machine and allowed to cool before moving on to the next stage of the process. The next important step in the process is to attach the sheave's hub. Before the hub can be installed, the donut is machined to its final profile, removing excess steel to reduce the weight and preparing the bore and faces for assembly. While the blanks are cut and roll forged, the hubs are made in parallel, so everything is ready for the sheave's assembly. Hollow bar is cut to length on a bandsaw, then transferred to a CNC lathe and machined to the hub's required dimensions. Each hub includes a machine step that ensures alignment in the donut before welding and offsets the weld to reduce residual stresses. Skilled welders fit the stepped hub into the center of the donut and weld it in place. This hub will later house the sheave bearing. With the hub attached, the sheave is ready for the next critical step: flame hardening. Flame hardening is a key step for long-term durability. The sheave's groove, the surface that carries the wire rope, is selectively heated with a torch and then rapidly quenched. This forms a hard, wear-resistant case around the tougher, ductile core. Here, the groove is hardened to about 35 on the Rockwell C scale. That hardness resists scoring and wear from the wire rope, while the softer core absorbs impact and helps prevent cracking. Only the working surface is hardened. The rest of the sheave remains machinable and tough. This balance extends the service life and helps protect the wire rope. After hardening, internal stresses from the heat changes are relieved using high-frequency vibration before proceeding to the final machining. With the hub welded and the groove flame hardened, the hub bore is brought to its finished size for the bearing press and fit, and the faces and diameters are trued for symmetry so the sheave runs smoothly. As important as the sheave is, there are many other parts and components within the block required for final assembly. While the sheaves are made, these components, such as pins and brackets, are machined by a team of CNC machinists, creating each integral piece of the block. The hooks for McKissick blocks are forged in Longview, Texas. Steel billets are heated in an induction heater. Once at their precise temperature, the billet is sent to the hammer forge. First bent to shape, before being slammed by closed die forging hammers, finalizing its shape, dimensions, and markings. Each hook is quenched and tempered to achieve the required strength and ductility. After passing all their quality checks, these hooks are then shipped to Tulsa, where they await their final application. In Tulsa, the hook shank is precision machined on a CNC lathe. Skilled operators check the diameters and shoulders to verify size and fit. With the machining complete, a collar is installed on the shank. And the hook is staged for final assembly. As part of the quality process, parts are tested to meet Kito Crosby's strict standards. Some of the components used with the crane block, such as these wedge sockets, undergo magnetic particle testing. Fluorescent particles are applied to the steel and inspected under ultraviolet light to reveal any surface cracks or defects. Every build starts here. The table reads like a map of the whole block. Plates, sleeves, pins, bolts, and sheaves laid out in reach. The work from across the shop ends up right here where it all comes together. Guide studs go into the bottom plate first, keeping the holes lined up and the stack square. Assembly begins on the hook. It's greased, and new components are added to allow for rotation and to keep the swivel smooth. Next, the positive locking hook latch goes on, and then we move back to the block. The center pin goes in. The next plate follows. Now it's the Sheave's turn. Installing the roller bearing is precision work. He presses the roller bearing into the sheave carefully and checks for alignment, so the sheave spins free and true. Back at the block, anti-seize is applied. A few more pieces of hardware, and the sheave is set in place. Spacers are set in place on the pins. Adjoining hardware is neatly organized and ready for use. The dead end connection, what holds the fixed tail of the crane rope, is added. On the Easy Reeve crane block, designed so the crane rope threads cleanly, the center connection point allows the dead end to be between the block's side plates, allowing for better block travel. After the dead end, the hook is lubricated and set in place. The hardware allows for dual action. The hook can rotate up to 180 degrees and swivel 360. A lift magnet handles the heavy plate so hands can focus on alignment. Meticulously aligned, then dropped cleanly over the pins, locking the dead end connection and the hook in place. Now comes the identification plate, the block's identity and accountability. Rated load, weight, manufacturer's name and serial number are required on every block. Final side plate. Washers and nuts. Torqued down tight and locked in place so fasteners won't back off under load. The work comes with the quiet confidence of people who build things the right way. What leaves this bench is trust that you can put your life in. Now the bearings are greased, spin test by hand, and the assembly is complete. It's ready for paint. You can spot a McKissick block by the blue and orange. First the blue, painted with precision, everything on the inside of the block. Then, on the outside. Next, the orange. Orange hooks and hardware, a signature of the McKissick brand, are more than just aesthetics. Orange for high visibility and a corrosion-resistant finish that helps the block withstand the elements. Crane blocks lift serious weight, often high overhead. There can be no doubt in their quality. Job site safety depends on it. Certain blocks are put into a calibrated pull tester and are pulled to a specific proof load, the verified test load above its rated capacity, and held there to confirm it will carry what it's built to lift. Now onto clipboards. Kito Crosby's name for the block's final quality check. Inspectors work the checklists, their clipboards, to confirm every spec and compliance with ISO 9001 and API Q1 is met. No stone is left unturned before each crane block is packaged and shipped to the customers. Sign off on the clipboard mean the block's ready to carry the McKissick name.
So this is the last step of the process. So finished product is going to be packaged up, and we're going to ship this product all over the world.
That's pretty cool.
We take a lot of pride in what we do here. It takes a lot of hard work to do what we do every day, and we're privileged to give you the opportunity to see what we do and just share our quality product.
Well, thanks for having us.
Thanks for being here.
From the pallets to the crates, from the scale to the truck, these blocks head out. On the road and over water, bound for work. Construction and infrastructure. Oil, gas, and energy. Industrial plants, military docks, the marine world. Shipped worldwide, ready to lift. Crafted with skill. Quality is a habit here in Tulsa. Heat and grit meet precision and patience. It's pride. Hands that know the weight of what they make. The potential cost of a mistake. The kind of work you feel on your shoulders. This is Tulsa work. McKissick. American manufacturing. A craft honed since the early 1900s. Work you trust with your life.
So that's how McKissick blocks are made, with hard work, skill, precision, pride, and purpose. Welders, machinists, and assemblers who carry the weight of their craft because the world counts on what they build to lift safely. If you need blocks or parts, Mazzella has what you need. Snatch blocks, crane blocks, oil field or construction, Mazzella distributes and supports the entire Crosby catalog. Mazzella can help with all of your lifting needs, from cranes and hoists to rigging, service, inspections, and training. We're your one-stop lifting shop. Feel free to contact us through the link below. If you found this video useful, informative, entertaining, or you just feel like being friendly, then hit that like button. Remember to subscribe so you never miss a video. Remember, safe rigging is smart rigging. My name is Ben. Stay safe out there.